All right, so for this problem over here, you have a sample of polonium-218. You're told the half-life of the sample, which is 3.05 minutes, T1 half. And we're also given the time here because we're told that it's going to be decaying for 52 minutes. So that's my time. And you're also told that there are 1.0 times 10 to the 12 atoms of polonium-218. And the keyword here is remaining, which is going to be the number of atoms that you have after time has passed. So this is going to be our NT over here. Okay, and you're trying to solve for how many atoms were in the original sample. So we're looking for our original sample, so NO. And we are going to be using natural log. And since our equation or our problem is asking for how many atoms were actually in our original sample, we're going to take a look at our natural log equation here. And looking at our first one that we have in our notes, you know that the natural log of your sample after time has passed minus your natural log after the original sample is equal to your negative k times time. Okay, so I'm going to go ahead and plug in for my k value over here, and we know that k is equal to 0.693 divided by my half-life. So it's 0.693 divided by 3.05 minutes for my half-life. So we're going to just go ahead and punch that out really quickly. It's 0.693 divided by 3.05. And we get our k constant, which is 0.2272 here. And the units would be per minute. Okay, so this is going to go into my k value right over here. We know the time, and I know that this is the thing that I'm trying to solve for, how much I had in my original sample. So natural log of NT, which is 1.0 times 10 to the 12 atoms, minus natural log of my original sample is equal to negative k, which is 0.2272, times my time, which is 52 minutes. Okay, so just to simplify this out, I'm going to take the natural log of my 1.0 times 10 to the 12 atoms, and we get 27.6310 minus ln here, and then I'm going to simplify out the right side. Negative 11.8144. Okay, and now I want to get rid of the 27.6310, so I'm going to subtract both sides by that number to get rid of it. Okay, now on this side I have a negative natural log left over. Okay, and if you take negative 11.144 minus 27.6310, negative 39.4454. And there's a negative here and there's a negative here, so that cancels out, just becomes positive. And to figure out what the n sub 0 is going to be, it's going to have to take the antilog of this number right here. So it's going to be e to the 39.4454. I'm going to look for that number on my calculator, 39.4454. And we figure out that our sample is 1.352 times 10 to the 17th atoms, and you would be finished after that.